All right, guys, welcome to 8.1 Part 2 notes. So we just got done talking about sequences. Now we're going to move right into series. So a series is the sum of the terms in a sequence. So if I took all of the numbers in the sequence and I added them together, that would be our series. So if I have a finite sequence, I'm going to have a finite series because there's only so many numbers I'm adding together. I can also have an infinite series if my sequence is infinite and goes on forever. So I can add all of those numbers forever and ever. Okay. So when we write our series, we have a different notation. So we use summation notation or sigma notation. I usually refer to it as summation notation just because we are adding all of the pieces together. So in a finite series, okay, notice I'm only adding a certain number together. I'm starting with the first term, and I am working through the fourth term. And this is telling me what to do each time. So my first term, I'm taking 2 times 1, I get the 2. 2 times 2, I get 4. 2 times 3, I get 6. 2 times 4, I get 8. So it's still a rule, just like what we were doing before. But now we're taking all of those pieces and we're adding them together. So I have my upper limit on top. That's where I'm stopping. I have my lower limit. That's where I'm starting. And inside I have my rule. And instead of using in like we did for sequences, we're going to use I. That's our index of summation. Okay, so the only difference between the finite series and the infinite is notice that I do have the dot dot dot, so that's telling me that instead of putting a number up on top, my upper limit is going to be infinity because it's going on forever. So let's go ahead and write each series using summation notation. So right here, I'm going to draw my capital letter E. Okay, it just looks like a big E. And on the bottom, we are starting with our first term, so we're going to write I equals 1. And we're trying to figure out what the rule is in order to get us to 250. So if this is my first term, second term, third term, how are these related? So it looks like each time I'm taking my term number times 25. Term number times 25. So what I'm going to do is I'm going to say this is 25i. So 25 times my term number. And I have to figure out how many numbers or how many times it would take me to get to 250. So if I'm multiplying by I, figure out what you would multiply by to get to 250. So you would have 10 terms total. And there's your answer. Okay, next one we're going to try. So we are writing our big sigma notation or summation notation right there. And I'm going to start with my first term. This time I have a dot dot dot, so I'm going to infinity. So infinity's on top. And I'm figuring out how these are related to my term numbers. So it looks like I'm using that term number on top. So I have I on top of my fraction. And then I have one more than that term number on bottom. So I have I plus 1 on the bottom. And there's my rule. Okay, we're going to try a few more of those. So here's my next one. I'm starting with my first term. That's a 6. And then I'm going to a dot dot dot. So I know I have infinity on top. So I just have to figure out how these are related. So I know 1 times 6 would get me here, but 2 times 6 would not get me to 36, so it's not a direct multiplication. So instead what I'm looking at is maybe an exponent. So 6 to the first could get me to 6. 6 squared is 36. 6 cubed is 216. So I'm actually looking at 6 to the power of my term number, so that I is an exponent there. Okay, next one. I have my first term, so I equals 1 on bottom. And then this one is very similar to what we saw on the first one of these that we did. So how are these related to my term numbers? Well, that is 1 times 5, 2 times 5, 3 times 5. So each time you're taking your term number times 5, 5i. And then I have to figure out what number this would be or what term number this would be. So this is a 20 on top, 20 terms to get me to 100. Okay, down here I have 1/2, 4/5, 9/10, and 16/17. So right away I'm seeing that the top is one less than the bottom, so that's going to help me when I'm writing my rule. Okay, I'm starting with my first term. I'm going to a dot, 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 so I know that's infinity on top. And I want to know how those are related to that term number. So I have I on top, it looks like I squared. Okay, and then on bottom I said it was one more than what was on top, so I have I squared plus 1. Okay, last one of these, it looks like I'm just adding 1 each time. And I'm starting with my term number plus 4, so I know that's going to be my rule out here, my term number plus 4. I'm starting with my first term, which is a 5, and I have to count up 8 terms to get there, so 8 is what goes on top. That's my upper limit. Okay, so what we're going to try now is actually finding the sum. So for me, I'm looking at this and saying, okay, well, I need to figure out what each term is and then add them together. But I also notice I'm starting at the third term. So I'm starting at where this is my third term, and then I'm working up until I get to my 8th term. So I'm going to start by plugging in a 3 for that I. So I have 3 plus 3 squared. Then I'm going to add all my terms together, so the next one will be 3 plus 4 squared. And then 3 plus 5 squared, and then 3 plus 6 squared, and 3 plus 7 squared, and 3 plus 8 squared. And I'm adding all of those together, so what I'm going to do first is actually figure out what each of those are. So when I simplify, remember you can pause the video at any time, I have 12 plus 19 plus 28 plus 39 plus 52 plus 67, and when I add all of those together, I get 217. So the sum of this series from the 3rd term to the 8th term is 217. Okay, so some of them will be long and some of them will be a little bit shorter. So this one actually says to start at the 4th term and end at the 5th term. So this one's a little bit shorter, and I'm just plugging those in for that I. So I have 2 times 4 plus 2 times 5. I'm simplifying that to 8 plus 10, so my answer here is 18. So from the 4th term to the 5th term, my sum of my series is 18. Okay, so sometimes that's a lot of work in order to figure out what those summations are, so there are a few shortcuts depending on these special series. So for the first one, if I have sum of n terms of 1, so this is my rule, okay, I'm just taking 1 and I'm adding it repeatedly. So 1 and 1 and 1 over and over again, then I'm just going to have the sum of that series be however many terms there are, okay? So this one would just equate to our number of terms. Next, we're going to have the sum of the first n positive integers. So notice that I am plugging in my term number. So this would be like 1 plus 2 plus 3 plus 4. So there's a shortcut here, which is this formula. So we're going to take the number of terms, and we're going to multiply that by the number of terms plus 1 over 2. Okay, and the last one is the sum of the squares of the first n terms. So I'm taking each term and I'm squaring it, 1 squared plus 2 squared plus 3 squared over and over again. So here's my shortcut here. I'm going to take n and plug that in 3 places, and I'm going to simplify. So let's practice with some of our special cases. So the first one here, I have my series going from 1 to 5, and I notice that it is 9i. So if I look back, I don't have any that actually have those numbers in the rules, but it's closest to this one in the middle, and it's just saying I have 9 times that, so 9 times whatever that is. Okay, so my rule on this one was n times n plus 1 divided by 2, and the only thing I'm changing is I'm going to take 9 times that. So I know I have 5 terms because 5 is my upper limit. It's on top of that sigma. And I'm going to simplify this, and when I plug all of this in my calculator, I'm going to get 135. Okay, second one, very similar, so I don't have any quite like this, but I do have one that's similar. It is just an I squared. So if I go back, it's the one on the bottom here, it's my I squared. So I'm taking 3 times that rule, and our rule was n plus 1, 2n plus 1, all over 6. Okay, and I have 8 terms, so I'm going to my 8th term number. So I am saying 3 times 8 plus 1 times 2 times 8 plus 1, all over 6. And for this one, I get 612 when I type it all in my calculator. And next, I have an example of that first special series. So I'm going to look back at it. This is the one where it was equal to the number of terms. So if I'm saying 1 plus 1 plus 1 7 times, then this one equals 7. Okay, on the bottom, this is very similar to that first question at the top of the page. So I'm going to take 8 times n plus 1 over 2, and this time my n is a 5. So I have 5 times 5 plus 1 divided by 2. So if you're separating them, remember you can always do that separately. So if it's easier for you to do the parentheses first and then plug it in, you have 8 times 15, which gets you to 120. Okay, next one, I have 1 plus 1 plus 1 34 times. So this one should be a whopping 34. And the last one is a good example of that middle formula for special series. So I'm just taking my n times n plus 1 over 2. And I know that my n, my number of terms, is 6. So I have 6 times 6 plus 1 divided by 2. And this time I get 21. Okay, that is all for 8.1 notes. Please make sure that you watch both part 1 and part 2 before trying your assignments. That way, if you have any questions, you know which section you are asking them about. All right, good luck on your assignment, guys. Bye.